Okay, so we are continue chapter 1. Okay, introduction. Complex numbers. So we know for complex, a complex number has the two parts, real part and image part. So this is an example. So a equals 1.8 minus 3.34. I we know is the image root, right? So 1.8 is the real part. 3.34, this is the image part. Then ABS. So let's do this in MATLAB. So A equals 1.8 minus 3.32. Sorry, 3.34. ABS. A is a complex number. ABS here, this will get the length of this complex number. Or we can see complex number A is a vector in coordinate system, right? So ABS, so is the length of that vector. So this actually equals SQRT square root 1.8 square plus minus 3.34 square, then square root. We will get the same number. So this is the ABS. Next one, real. So this get the real part. IMAG image. So this get the image part. So real, no. So real A. So 1.8 image A image part. So minus 3.34. Angle. So this get the angle of the vector. Okay, so this actually is the A times A, no, sorry, is the minus 3.34 over 1.8. This is in the radian, this thing. So you can see the same result, minus 1.065. Okay, let me clear. Conjugate. So this will get the conjugate of the original A. Okay, so this is original A. So just the image part from the negative goes to the positive. Okay, so this is the complex number. MATLAB functions. Length, if you have a vector. So this is the row vector. So let's just clear everything. CLC. So A equals 1, 2, 3. So you can see this is 1 by 3 vector. So row vector, 3 elements. Length A. So is the 3. Length A will get the maximum number from the size. Size has two numbers, row number and column number. So length A will get the maximum number between the row number and the column number. Then the next one, size. So size will give you the row number and the column number. So row number, column number. So let's do a little bit. So change 1 colon, semicolon, 2 semicolon, 3. So we know this is 3 by 1 vector. So now it's 3 by 1. So this is the column vector. Then length A, so you can see still is the 3. So maximum number between the row number and the column number of a variable. Okay, so this is a new one. Let me copy this one. So B, so B is the 2 by 4 matrix. First one, maximum B, MAS for maximum. Maximum B, this will get the maximum number in AV column. So column 1, 3, 2. So 3 is maximum. Column 2, 4, 5. So 5 is maximum. 5, 7. So 7 is maximum. 5, 8. 8 is maximum. The last one, minimum. So similarly, so this give you the minimum number of AV column. 3, 2, so 2 is minimum. 4, 5, 4. 5, 7, 5. 5, 8, so 5. So this is the minimum number in columns. Okay. Then sum. Sum B. So this if you get the sum of AV column, also in column. 3 plus 2, so 5. 4 plus 5, 9. 5 plus 7, 12. 5 plus 8, 13. The last one, so size. So C equals size A. Let's use B. Okay, we did it before. So 3, so 2 by 4. Okay, for matrix. So we said before. So in MATLAB, so AV variable is a matrix. Usually for a matrix like this. So this is matrix A. It has the M row and N column. Okay. So this is row 1, row 2, until row M. For the column, so column 1, column 2, column 3, until column N. So for AV element, it has the 2 subscript number. So the first one, so is row number. The second, this is the column number. I said this before. For this matrix, so it's the n by n matrix, n by n. Then A, I, J, so I is the row number, J is the column number. So this is an element in matrix. If n equals 1, so matrix A actually is a column vector. If m equals 1, then A is a row number. M equals n, then we said A is a square matrix, so square matrix. If matrix A and B have the same number of the rows and the columns, so we can do addition, subtraction. For example, so C equals A plus B. Then the result elements in C, so that's the elements in A and B adding together. So C11 so equals A11 plus B11. C12 equals A12 plus B12. Okay, so just like this. Similarly, subtraction. Subtraction, so C equals A minus B. So that's the elements do subtraction. So A11 minus B11, A12 minus B12. A22 minus B22. Okay, like that. So we can do this in MATLAB. Clear everything. So you can use clear all. Okay. COC. So A equals 1, 2, 3. Okay, use more. So 5, 5, 6, 7, 8. So we know this is a 2 by 4 matrix. For addition and subtraction, matrix should have the same size. So we can do this 8, 5, 3, 6, then maybe 1, 9, also 9, 2, 7. Okay. Oops, let me use B. Then A plus B. So you can see 1 not clear. Let's do this again. So A, B, A plus B. So 1 plus 8. So that's the 9. 2 plus 5, 7. 3 plus 3, 6. 8 plus 6, so 10. 5 plus 1, 6. 6 plus 9, 15. 7 plus 3, 9. 8 plus 7, so 15. That's the addition. So for checking, A minus B. 1 minus 8, so minus 7. 2 minus 5, minus 3. 3 minus 3, 0. 4 minus 6, so minus 8. 5 minus 1, so 4. 6 minus 9, minus 3. 7 minus 3, so 4. 8 minus, also 8 minus 7, so it's 1. So this is addition and subtraction. Then multiplication. Multiplication, so is a little bit different. For multiplication, only when the number of the column in A equals the number of the rows in B, then can do multiplication A times B. Okay. So here, this is example. So A now is the 2 by 3. So row 2 rows, 3 columns. Then B is a 3 by 2. So the column number A equals the row number of the B, right? Then we can do multiplication. C equals A times B. So the result is a 2 by 2 matrix. So it's here. So A is M by N, B M by K. Then the result is the M by K. So M rows, K column. Then Cij equals sum. So sum of the Aik times Bkj. Okay, K from the 1 to N. Okay, so actually for this one, so you can use this way. So C11 then equals row 1 in A times column 1 in B. Then C12, so that's the row 1 times B2, B column 2, C21, so that's row 2 times column 1. C22, so that's the row 2 times column 2. Okay. Then we can get this. Okay. Okay, so let's do this in MATLAB. So A is the 2 by 3. Okay. So 1, 2, 3, 4, 5, 6. B is 3 by 2. Okay. So maybe 6, 7, 8, 9. So 1, 2. Okay. Okay, so this is 3 by 2. Then C equals A times B. So 25, 31, 70, 85. So we can see C11. C11 is the row 1 times column 1 in B. Okay. So let me do something. Okay. So that's the 1 times 6 plus 2 times 8 plus 3 times 1, right? So row 1, column 1. Okay. So this equals 6 plus 16 plus 3. So 6 plus 3, so 9. 9 plus 16, 25. So this is C11. Then C12, this one. So row 1 times column 2. So 1 times 7 plus 2 times 9 plus 3 times 2. So equals 7 plus 18 plus 6. So this is 25. 25 plus 6, so 31. C21. So row 2, column 1. 4 times 6 plus 5 times 8 plus 6 times 1. So equals 24 plus 40 plus 6. So 64 plus 6, 70. Okay. The last one, C22. So row 2 times column 1, 2. Okay. 4 times 7 plus 5 times 9 plus 6 times 2. So equals 28 plus 45 plus 12. This one, so 73 plus 12, so 85. This is correct. Okay, so this is the multiplication for matrices in MATLAB. So very simple, so you can just do the multiplication, put the multiplication for numbers. Transpose, so like the rotate a matrix by 90 degrees. So this is original A, so it's M by N. Then B equals A subtract superscript T, or A equals A prime. So equals, so now it's N by N. So row in the matrix, original matrix A, now is the column in matrix B. So row 2, column 2, row M, so column M. So you can see like rotate by 90 degrees. So B is the N by M. Okay, so we have this one. So for example, this original A, then A prime. So now it's 3, ANS 3 by 2. 1, 2, 3. So 1, 2, 3, 4, 5, 6, 4, 5, 6. So this is transpose. Identity. So identity matrix is a special matrix, just like the number 1 for numbers. Okay. So identity matrix, I times A equals A times I equals A. Okay. So identity matrix I, you can see just the diagonal elements have the value 1. Other elements just 0. Okay, just 0. So only element, diagonal elements have value, so 1. Inverse. So inverse matrix, so that's the A minus 1, A power to minus 1 times A equals A times A minus 1 equals I, identical. Okay. So like the inverse number in numbers. Okay. So for this one, only square matrix has is inverse matrix. Okay. Not the all matrix in not all square matrix have the inverse matrix. They are corresponding inverse matrix. You learned this in mathematics, right? So for getting an inverse matrix, so we can just use this function inv. So inv. So now we need a square matrix now. So clear all. Clean. So A equals, maybe let me get this. So 1, 1, 1, 10, 3, 5, 4, 2, 9. Let me check. 2, 8, 9. Actually, I'm not sure whether we can get inverse matrix from this matrix A. We can try. So inv A. Okay, we get this. Okay. So, for example, we can assign matrix A is the inverse matrix of the original A. So, okay, let's show this now. So the same one, then B times A. So this is the identity matrix. So 1, 1, 1. Other are zeros, right? Similarly, so this is A times B. Actually, I forgot. Last one is B times A or A times B. So just get the identity matrix. So 1, 1, 1, 1, 1, 1. Other are zeros. Here, minus 0 still is the 0. This because from the algorithms, this number maybe is just close to 0. Okay, so this is inverse. Okay, the last one of the matrix, so determinant. Determinant, so we use this function, det. Okay, we can still use this one. So det A. So this is the 250. So determinant of a matrix is just a number. Only when dt determinant of a matrix is not 0, then we can get an inverse matrix for the original matrix. Okay, so these some examples, so you can do by yourself. Okay, let's just do this. Okay, so clear all. CLC. So A equals 1, 3, 3, 5. A equals 1, 3, 3, 5. B, so this is a square matrix, so 2 by 2. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, at the beginning, so we can do addition. So A plus B. We said before, this is just the elements do addition. So 1 plus 1, 2. 3 plus 2, 5. 3 plus 3, 6. 5 plus 4, 9. A minus B subtraction, similarly, 1 minus 1, 0. 3 minus 2, 1. 3 minus 3, 0. 5 minus 4, 6, 1. So that's the multiplication. So A times B. Okay, so let's clear first. So A times B. So now we need to get this. So C 1, 1. So row 1, column 1. So 1 times 1 plus 3 times 3. So we know this is 10. Row 1, column 2. So 1 times 2 plus 3 times 4. So 40. This way. Row 2, column 1. 3 times 1 plus 5 times 3. So 50, 3, 80. Row 2, column 2. 3 times 2 plus 5 times 4. 6, 20, 26. Okay, so then this one, the last one, division. So A divided by B. Division, so actually we talk about this later. So A divided by B, you get this one. So this actually equals A times inverse of the B. So you can see A times A B, you will get the same result. So 2.5, 2.5 minus 0.5 minus 0.5, 1.5, 1.5, 0.5, 0. So exactly the same. So A divided by B equals A times inverse of the. Then the last one, transpose. So B prime. Original B prime. So 1, 2 in row, then 1, 2 in column. 3, 4 in row, 3, 4 in column. So just like rotate by 90 degrees. Okay, so this is the week 2.